A very good day, I bid to Dr. Musab. Today we are from Group 10, which consists of Nur Farhanny, Roobaraj, Nizar, and Nur Syafiqah, will be presenting about Aloha analysis for accidental release of ammonia from Asian binti fertilizer Sindiriam Berhad, which is located at Tanjung Kidurong, Sarawak. Now, let us have a look into the input data into Aloha software. Pure ammonia is stored in the facility at -32 degrees Celsius. As in for the atmospheric data, the weight is predicted to be at the speed of 6 kph from north-northeast at 3 meters, while the air temperature is assumed to be at 26 degrees Celsius. The relative humidity is assumed to be 84%, while for the source strength of each scenario, the type of tank is sent in the facility are vertical cylindrical tank. The tank diameter is 50 meters. The tank length is 40.5 meters. The tank volume that occupied by liquid is predicted to be 80% with the temperature of -33 degrees Celsius. The leakage of opening is predicted to be a circular opening with 3 different diameters for each scenario, which are 0.1016 meter, 0.14605 meter, and 0.01905 meter. The leakage of a height from the tank bottom is predicted to be 12 meters. Aloha had conducted 3 different types of studies based on the input data that have been entered in. So the first study is about flammable chemical is not burning as it escapes. So in this, first we will be looking into the downwind toxic effect. As it is presented in the table of level of consent for toxic gas release, the second scenario has a larger radius for all 3 zones as compared to the other 2 scenarios. This is well supported in their individual risk contour on the toxic gas release for the scenario 2. As in for all 3 scenarios, the red zone covered a large part of the facility and the Jalan Kidurong Street, and along with some cafes and a small part of the Bintulu Port. As in for the orange and yellow zones covers a large part of the Bintulu Port and MPT Sarawak. Now we'll be looking into the vapor cloud dispersion flash fire. For this, as we can see, both the red and yellow zone have LEL of 10 and above percentages, which is 60% for red zone and 10% for yellow zone. Thus, it is considered to be hazardous when they are trapped in a confined space and may explode or can be flammable when they come in contact with ignition sources or sparks. So from the table, we can see that the second scenario has a larger radius for red zone and also yellow zone. For this, the red zone is not drawn because effects of near-field patchiness makes dispersion prediction less reliable for short distance. Thus, and it's well supported in the individual risk contour for flammable vapor for all 3 scenarios, that the second scenario has a larger area compared to the other 2 scenarios. Now, we'll be looking into the overpressure blast force dispersion from vapor cloud explosion. The threshold pressure from Aloha is predicted if there is a new occurrence of flame due to the ignition of spark during the leakage. So from the table 6, we can see that the red and orange zone are not drawn because the pressure in gas in the zone due to the leakage are not exceeded the default pressures, which is 8 for red zone and 3.5 for orange zone. As in for yellow zone, the second scenario has a larger area compared to the other 2 scenarios. So it is well supported in the individual risk contour for blast force B. It has a larger surface area compared to the other 2 scenarios. For our case, the vehicles are parked near to the yellow zone, thus the glasses, windscreens, or the mirrors of the vehicles can be blasted or shattered during the explosion that had occurred.
The study of different types of scenario, which is scenario 1, scenario 2, scenario 3, was carried forward to different type of release, which is chemical is burning as a jet fire release. As you can see in table 7, the source strength of jet fire comparative for each scenario release, it shows that flame length, burn rate, and total amount of burn shows that scenario 1 has the highest compared to scenario 2 and scenario 3. This is of course makes sense because the scenario 1 leak size is the biggest compared to scenario 1, scenario 2, and scenario 3. And next is focusing on total amount burn, which shows that scenario 1 is 8,000 plus compared to scenario 2 is 5,000 plus and scenario 3 is 2,000 plus. And all the type of escape is actually jet fire escape. So this let us analyze furthermore. There's the threat zone for each of these differ if the amount of burning is differ. So when you do the threat zone for jet fire comparison, we found out that all the threat zones show the same value. which is for red zone or orange zone for three type of scenarios are same. But for the yellow zone only, the scenario wants a slightly bigger radius compared to the next slide. The zone of threat of jet fire for all three scenarios shows the same because it is too small to identify the different interchanges because of the leak size small. Hence, the radius is smaller than 1 kilometer in range, and this study makes us to understand that if there's a jet fire occurs, the probability of getting injured is in a smaller radius compared to if the explosion occurs or something occurs, then there might be a higher chance of getting injured. So this might show us that uh, this flammable study of jet fire release have less significant effect in our studies for the release if the ammonia is released from the leak. So the threat of at a point of jet fire comparison, we put the point to be at that particular field of red zone where we found out that the maximum energy per square meter is for scenario 1, scenario 2 and scenario 3 is differs where the scenario 3 is the highest compared to scenario 2 and scenario 3. This shows that because of the small size, the thermal energy, the kinetic energy when we disperse from the internal tank is changing to thermal energy where it shows a high rate of energy exchange which causes to be max amount of energy to be highest compared to scenario 1 and scenario 3. Despite all these changes, it still shows that this effect is less dominant compared to other types of release. Next, we are going to focus on belief, which is tanks explodes and chemicals burning in a fireball. So as you can see that again we did a study of source trend, and it is surprising showing that all the scenarios shows the same the fireball diameter, same duration, same full fire diameter, and flame duration also same, including flame length. This proves that despite the different leak size, when there's an explosion of a tank occurs, it mainly caused by the amount of liquid or amount of chemicals inside the tank, which caused the explosion to occur, not the leak size. The leak size just initiates the explosion to occur. So moving on the threat zone of fireball comparison, it is still the same for all these three cases because as I mentioned before, the amount of chemical inside the tank that leak size in this case. So that this shows that different leak size, despite different leak size, still the it only initiates the belief action, but when the bleed occurs, it's still solely depending on the amount of chemical inside it. So whenever the bleed occurs, that means at the starting point of the tank leak, it already start to explode. So that explains why the all of three having the same radius. So as you can see that this is a threat zone you can see compared to for all three scenarios. The red zone is the biggest that covers almost 70% of the plant compared to the orange zone which is covers the next portion of the 30% of the plant. The rest yellow zone is covering some part of the some part of a bintulu pot, some part of the other mlng storage, and also some part of the uh, afcb part outside its area. This is shows something that we need to take care. If there's an explosion occurs, we need to take care of this radius of study in order to avoid any other unwanted accidents to occur. Next is accuracy of results and limitation in the Aloha studies. In real life, there's a lot of consideration need to be taken in order to solve the Aloha situation. But in Aloha studies, there's a few limitations that can be observed from. They stated a few of them. Is one of them are very low wind speeds, very stable atmospheric conditions, byproduct from fires, explosion, and or chemical reactions, particulates, chemical mixtures, wind shifts and steering effects, terrain and hazardous fragments. So when we're focusing of byproducts and from fires and explosion and chemical reactions, Aloha doesn't account for the byproducts of the combustion such as smoke or chemical reactions. Next, for the particles parts, Aloha does not account for the process that affects dispersion of particles, including radioactive particles, as same as the Chernobyl cases there, where the radioactive particles exploded, but they didn't realize it until a further investigation was carried out. So this is very dangerous if we cannot identify it. The next is chemical mixture. Aloha is designed to model the release of and dispersion of pure chemicals that in our case is ammonia and a few select solutions. The property information in this chemical library is not valid for mixtures of chemicals. So this makes us hard to analysis if there is a mixtures of chemicals. Next is wind shifts and terrain and steering effect. Aloha assumes that the wind speed and direction are constant throughout the area of downwind of chemical release, which is hard us to understand when there is a different direction and a movement of wind in that particular release. Next is terrain. Aloha also assumes that ground is flat, which has a different implication depending on the release scenario. And finally, hazardous fragments, and if a chemical release involved in explosion, there will be a flying debris from the container which surrounding the area, and Aloha does not model the trajectories of the hazardous fragments. And for a very low wind speed and very stable atmospheric conditions, at a very low wind and very stable atmospheric conditions, we can observe that there is no significant change of the wind and also the atmospheric thus the vapors tends to stay at near the point which can initiate further reaction if not handled properly.
Let us have a look into the comparison of the results with literature. Firstly, we look into the moral dispersion of the LOC are the result of a constant wind speed and direction and did not take in consideration of the changes of the wind steerings. Secondly, Aloha predicted that the concentration of ammonia will be at highest surrounding the release point and drops gradually in the downwind direction, which is not true when it comes to the real situation. In reality, wind eddies push a cloud of unpredictably causing gas concentration at any moment to be unpredictable. Next, Aloha set the mass of ammonia to be aligned with the percentage of tank filled to predict the result at the worst case scenario. But it is totally different when it comes in the Fourthly, Aloha estimates the concentration of gas cloud is a mixture of gas and aerosol. This is because Aloha assumes that the chemical instantaneously becomes a mixture when it
Hi, my
is
name is Nur
released
Syafiqah
into the
Debayan,
atmosphere.
matrix number
Lastly, Aloha
19895.
only
So,
modeled
as for my part, I
dispersion
will
of
present
toxic
about the
gas,
individual risks
thermal
present in the
radiation,
ABF
and blast
plan.
areas.
The individual risk is the risk analysis of fatality and injuries towards the people who are within the zone impacted by the hazard. The most prominent zone of the individual risk per annum is identified as the red zone. This is because it has the potential load distance for the level of concern LOC. Table 11, this here table shows the risk analysis analyzed for individual risks at LOC for all three scenarios. As you can see here, the consequences for all events for each of the scenario, the longest consequence distance will be the toxic effect, followed by the fireball, then flash fire and jet fire. The effect for individual health, according to the consequences event, is from ranging from the minor injuries to as severe as fatalities. The workers exposed to the LOC area are approximately 50 to 200 workers. Despite all the hazard and effect of the ammonia threats toward the individual, it still can be minimized by usage of PPE, personal protective equipment, and within a safe shelter distance. Next is about the societal risk. Societal risk is the analysis of the risk of more than one chain-linked fatalities and injuries in the society. The society would have to be affected by the hazard causing a number of deaths, injury, financial, environmental, and other losses. In this study, the population inside, which are the floating population, tourism and port, and around the plant, major plant location, was estimated to analyze the impact of the release for all three scenarios. Here, table 12 shows the potential risk effect of the society from all three scenarios. For all color of zone, they have similar consequences for health and safety value, environmental values, financial loss exposure, and finally, population severity.
Hi, I'm Farhanny. So now I'll present about the purpose recommendation. There are a few purpose recommendations need to consider in order to prevent the accident happen. And one of it is use appropriate defense devices. Defense devices such as safety valves or braking diaphragms with the operational pressure is not greater than pressure 1, as the range of cross-sectional areas and minimum superheating limit are enough to reduce the elevation of pressure in a fire. This is because the liquid temperature is lower than superheated liquid. The evaporation of liquid will form slowly, thus a strong aspiration does not occur. Furthermore, The fire alarm system should be installed to help in early warning of fire. There's the fire detection and sounding devices in the system. The fire detection will sense a smoke, then it will activate the fire system and the sound. Therefore, the workers will be more alert as can help to prevent the fire from becoming violent. Next, the vessels also can be insulated with a fire protective insulation such as cementitious fireproofing, as it can delay the effects of increasing temperature and control the fire. In addition, in order to prevent jet fire accident from happening, the safety management, emergency preparatory, daily monitoring should be enhanced, and the maintenance should be done frequently by the facilities. Besides that, the organization also needs to implement the fire regulation, include the control of fire source, increase the public safety and the education of the fire accidents, and starting the emergency plan of fire to lessen the impact of the accident. Moreover, the organization should train the workers in handling the firefighters' equipment as an emergency response to deal with the fire, and the emergency responders also need to keep the distance far away from the accident. Furthermore, the peripheral personnel should be organized frequently by the facility to leave the accident area as soon as possible, and the source of fire need to be shut down as per maintaining the access control to the accidental area. The access control can be done by allocate the accident area as the danger zone. That's all from us. Thank you.